py given x, conditional probability of x given p of y. This one is given to you. This is just a number. Specific numbers given to you. For example, like a table, right? P, y given x, and then suppose that it was a binary. This one is given to you. These are numbers, right? They are not variables. That's what this means, okay? All right, so maybe for one more time, if I emphasize, right? Given x, maybe this one, maybe 1/3, 2/3. Given x equal to 1, right? This was something like that. So they are number. So numbers are given to you, right? They are not variables, right? So this part is given to you as numbers. And then now I need to talk about convexity of this function over single variable now, px. Okay. So what do we need to prove for this? So this was given to you. What do you need to prove for this? Can you set up the problem? In order to prove this, what you need to do? Can you set up the problem? You need to have an objective, right? Here, Carver and Thomas says this, right? Mutual information, h of y minus h of y given x. And the h of y, we have proven it is a concave function of py. And h of y given x, right? This is a linear function of px. That's the only explanation Carver and Thomas give you. But with this, can you make sure that this statement is true? It's not tricky. It's not clear, right? 100% clear. Maybe this part is okay because we have proven. But what about this part? Right? It's not 100% clear, right? 쉽게 말해서 찝찝하지. 이거 옆 사람한테 설명하려면 잘 모르겠는 거지. 그지? 카버가 그렇다 그러니까 그런 거지. 그지? 그렇게밖에 말을 못 한단 말이야. 그럴 때는 어떻게 해야 돼? 그 얘기를 하는 거지. 이럴 때는 어떻게 해야 되느냐 말이지. 그러면 concavity 펑션의 정의 알았잖아요, 우리가. 그지? 그지? 그거를 이용해서 한번 보여주면 돼요. 뭐 어떻게 해야 됩니까? So how do we show this? Maybe it is right, but if we wanted to prove it by ourselves using the technique that we learned so far inside the class, okay? So how should we do? What is the first thing that you have to do? First step. What is the first step? So py given x is given to you, right? Now we want to show that mutual information x and y is convex over px. That's what we want to show, right? That's what we want to show. So what do you need to immediately think? How do you take the average of function? And then function of average, we need to know, right? So in here, the only input that we can vary is this, because that one is given to you, right? Is what? P1. So Px. Then I can think about 2 points, right? I need to think about what should be x1 and x2, right? These 2 points, right? But what will be those 2 points in this problem? I wanted to show this. So our goal is to prove or disprove that this is true or false. So basically, goal is to prove this statement, right? So what do we need to do? Basically, notation is very important. So you pick 2 points in the vector space, right? So P1x I will choose, right? Because this is about, choose a 2 point, 2x, right? Right? Okay? And then I need to talk about average of 2 points, right? Then, once you have chosen, you can let P of lambda is equal to lambda P1x. Can we do this, right? Right? I can do that, right? Okay. Then, basically, if I have these 2, all I have to do is realize that one, right? Function of average. Function of average is greater than average of function. So here, that function is mutual information, right? The function is mutual information. The function is mutual information, but this part was given to you. And the only part that I am allowed to vary is P1 and P2, right? Input distribution Px, right? So in this particular case, then here average of this convex, average of function, right? Average of function greater than or equal to function of average. I should remember this, right? And average part is already given here, right? Average part, right? And then average of function, I have to use that one for that one, P1 and P2, okay? That's it, right? But here, one thing that we have to be careful is that this one is a function of joint and product distribution, right? That one. So I need to create joint distribution with this one, right? And that one, right? When you use that one, right? So that's the only part that you need to be careful, okay? And then if you apply that, then basically I send you the note this morning because I don't want to do that on the board, right? Is this one right here, showing the concavity of mutual information. So I have done this for you, right? So showing this, basically what I have just said, using P1, and you just need to pick 2 vector, P1 and P2, and then do the mixing, lambda, P lambda, and then create the joint distribution and the product distribution for this, okay? All right? So that's all you need to do. Then the joint distribution for P1 is what? P1x times Py given x, right? And P2 jointly with the x and y is P2x times Py given x. But the Py given x part, again, given to you, they are just numbers. You just treat it as a number, even though I have still as a variable form, right, x and y's. But because of this language, I'm going to treat them as a number, right? Not a variable, okay? So that's all you need to do. And if you mix the 2 joint distribution, you obtain this, okay? All right, lambda times P1 x and y, 1 minus lambda times P2 x and y. And then how do you obtain the marginal? Obtaining the marginal from the joint distribution, we have done many times. So it can be done this way. So after you have done that, you know the joint distribution for x and y, for P1 and P2, and the joint distribution for mixed case, right? And then now I'm going to use a notation for average of function, this one. So here I have to use joint distribution, right? What we have just named. And this one for sorry, this was a concavity. This one was a convex. Sorry. Sorry. All right. So in order to minimize this type of mistake, I am drawing the picture but still making mistake. All right. So this was the other way around. We wanted to show that mutual information is concave. So concave. Always right or left, up or down, always confusing. All right. So this one goes the other way around. Sorry about that. All right. Then this part right here is this one, right? And each function of average, average of function is this part, right? Okay, sounds good. So you guys take a look at that note when you get home, right? So that one. That is the notation. I am not using P1 lambda, right? Right. Function of average. average of function, right? inequality goes 계속 헷갈려. 그려놓고 해야 돼. 그지? concav이지? function of average. average of function is 이거죠? 맞죠? 아니 계속 헷갈려 이거. 여기서 I need two distribution, right? joint and product. joint and product, right? P I need to calculate this using P1x, right? And P2x, right? P1x, Py given x. This part is number. It's given to you. This one is the only variable. So I am using the subscript. Okay, that's what I'm doing. P2 So this part is significant, right? And then what about P lambda x? Like this, right? We get this. So we get all three well defined so that you can find out joint and product distribution for that one. And then joint and product distribution for that. Joint and product distribution for this, right? Right? So that's all we need, right? 아직 다 나를 따라오는 것 같지는 않네. 그러면 한번 해볼까요? 요 칠판에서. 그러면 what is the joint distribution for that? 여기서 써먹어야 되는 joint distribution. How do I get it? 요거죠? 요거죠? product distribution. I need a product distribution. 여기서 써먹어야 되는 what is the product distribution for that one? 네? P1Y? 요걸로 해서 했다. 노테이션, 그 노테이션 그렇게 합시다. 그러면 P1Y라고 합시다. 그럼 what is P1Y? How do I get it? P1Y. Oh, I have this one, right? Joint distribution. From here, how do I get P1Y? 여기서 서메이션의 아규먼트가 뭐가 돼? X. 됐죠? 이런 식으로 구하면 되잖아요. 그죠? 그러면 노테이션만 바꿔갖고 저거고 요거를 사용하면 되는 거고 joint product 또 그 다음에 여기는 여기도 어려운 거는 joint distribution만 잘 찾아 놓으면 끝나잖아요. 그죠? What is the joint distribution for that one? That one is average of the two. 그죠? 그러면 P 라무다 joint라고 define 합시다. definition이라고 하자고. definition. 응? 라무다 먼저인가? 라무다 P1 X and Y 1 마이너스 라무다 P2 X and Y 그럼 끝났죠? 이렇게 하면 되죠? 승민? 이렇게 하면 되겠죠? 그러면 여기서 저게 조인트고 프로덕트 디스트리뷰션이고 저걸 가지고 프로덕트 디스트리뷰션 만들 수 있어요, 없어요? 만들 수 있죠. 과정은 똑같지 뭐. 그러면 여기서 P 라무다 Y 그죠? 너는 어떻게 해? 저것처럼 X에다가 P 라무다 XY 이거 다 해버리면 되잖아요. 그죠? 요게 주어지면 다 나오잖아요. 그죠? 그죠? 그렇게 해서 집어넣은 다음에 쭉 데리베이션 해보고 해봤더니 그게 홀딩 하더라 라고 하면 true. 해봤더니 뭔가 컨트라딕션이 있거나 그러면 not true. 이렇게 되겠죠. 그거를 한 거가 이 노트예요. 그거를 한 거가 이 노트인데 이렇게 해서 쭉 따라가 보세요. 따라가 봐. 근데 여기는 수학이기 때문에 보는 거가 인업인가? 보는 거 아무 소용없다. 남이 하는 거 보는 거 아무 소용없고 자기가 직접 해보는 거밖에 없다. 근데 자기가 직접 해보는데 우리가 어플라이 해야 될 룰은 첫 시간에 배운 거 그거밖에 없다. 그걸 가지고 모든 어려운 디어럼 다 나온다. 다 데리베이션 가능하다. 그거에. 그래서 나머지 거는 해보세요. 그 수업 시험에도 이런 거를 물어볼 거라고 나는. 그지? 왜 그런지. 이 라인에서 다음 라인으로 왜 그게 참인지 거짓인지 이런 걸 물어볼 거라고. 그러면 그거는 공부하도록 요구를 했으니까 넘어가고, 그 다음에 다시 인포 티오리 노트로 돌아가겠습니다. 그래서 이렇게 이제 이게 sequence of results so far인데 relative entropy is non-negative 이것도 증명했고요. relative entropy is zero if and only if two distributions are identical. proved. entropy is maximum when uniform distribution. 요거는 근데 컨디셔닝이 있는, 요거는 요 자체로 true는 아니에요. 나중에 x가 이제 어떤 랜덤 베리어블이냐, 디스크리시냐 아니냐, 또 다른 조건이 있느냐 없느냐에 따라서 달라지는. 챕터 2에서는 valid, 그지? 챕터 2에서는 valid. Mutual information is relative entropy. Mutual information is non-negative. Mutual information is zero if and only if x and y independent. X independent and going the other way, right, from right to left is easy because you just substitute, but going the other way from left to right, that is the difficult part, but we have proved that. And then because of the mutual information characteristic, we can also say, that conditioning reduces entropy. And entropy is concave function of distribution, you can say. And the mutual information is concave function of px given y given x, which is what we just have proved. And this part is very important. This part will be used later on in chapter 5 and 7, 6 and so in the later part of the chapters utilize this heavily. And I can ask you another proof, let's say this one. I can show that, I can ask you if this mutual information is concave function of py given x, given px. Now I give you px, I'm asking for the functional relation with respect to py given x. But rule is exactly the same, right? Apply that type of method to show that. And homework number 1 and right, and I have to give you homework. Where is the whole note? So there is a homework problem right here. Right? I see. Yeah, I think you can start doing the homework number 2. So I'll have the homework number 2 to be due Monday next week. Okay? Monday next week. All right. So, and then after that, I will move on to homework number 3 materials. All right. So, do you have any questions? So Monday next week we'll have a homework number 2 due. Yeah.
다음 주 월요일 개천절.
맞췄어. 아, 아주 잘했어요. 그러면 괜히 개천절날 숙제하고 있기는 좀 그렇잖아. 그 수요일 날 합시다. 수요일 날. 수요일 날 due. In front, before the class.
근데 그 수업 원에서 밤에 안 먹어가지고 교수님 다음에 같이 하면
아, 그거 좋은 생각이네. 그거, 그때 못했던 거 합시다. 그때 못한 거.
저걸 안 하고
아니, 왜냐하면, 호목 넘버 2가 제일 중요하다니까. 얘를 모르면은 뒤에 가봤자 그냥 까만 건 글씨고 하얀 건 백지요 이렇게 하고 있어. 다 그냥 쉬고 있다니까. 얘를 알아야 그때 자기 자신을 인게이지 할 수가 있어. 챕터 2는 천천히 가는 게 맞아. 무조건.
그 추가 내주신 것만 하면 되는 건가요?
그렇지. 그거 하고 요거. 아, 그거 해야 돼. 왜냐하면 안 하고 지나가면 이게 계속 헷갈린다니까. 이게 쉬운 게 아니에요. 이게 우리가 책 보고 뭐 렉처 노트 들으면 알 것 같지만 혼자 앉아서 하려고 그러면 안 된다니까. 해봐야 돼. 해봐야 돼. 그거 해봐야 돼. 좋은, 잘했어요. 오케이. 거기까지 합시다. 그러니까 뒤로 가면